we're going to define some very basic terms when it comes to functions. We're going to define relations, functions, domain, and range, and we'll do that through the use of the most simple representation, a mapping. Okay, now there's a lot of basic information in this video to get you going on functions, so if you need to pause and rewind, feel free to do so. So rather than telling you what a relation is first, let me give you an example of a relation. If you can visualize it, I think it will help us understand what a relation is, and then we'll formally define a relation. So let's say that we have this oval over here, and within it there are some real numbers, meaning, for example, numbers that aren't real are square roots of negatives or fractions that have 0 in the denominator. Okay, so we're going to avoid those. We're going to deal with real numbers only. And so let's see, a real number is 3. Another real number is the square root of 28. Another real number is negative 7.9 repeating. I'm just doing this to emphasize that you could have any sort of number in here that's real. And let's come up with one more. How about 7 over 12,000? Okay, so there are some real numbers. And let's call this group, this set of real numbers, the set of inputs. Okay, and then of course if we have some input real numbers, let's have some output real numbers. Let's have negative 24, 37 fifths, and the fourth root of 100. Okay, and so a relation will take and relate the inputs to the outputs. Okay, so let's call this relation R. So I'll label that up here. That'll be the name of this relation. And a relation relates the numbers in the input as the input numbers to the output number. So let's say 3 is related to 37 fifths, and 3 is related to the fourth root of 100. And let's say the square root of 28 is related to negative 24. And negative 7.9 repeating is related to the fourth root of 100. And let's say 7/12 thousandths is related to the fourth root of 100, 37 fifths, and negative 24. So you can see R is a rather complex relation. R is defined by this sort of web here in the middle that tells us how the inputs relate to the outputs. Okay, so we can say that the input of 3 is related to the output of 37 fifths, and we could go on and on and on describing all of the different relationships that make up the relation R. Now, by looking at this picture, it's pretty easy to understand the relation R. This picture, this entire diagram altogether, is called a mapping representing the relation R. Sorry about that, not B, but the relation R. So a mapping always takes and shows the inputs, the outputs, and simply connects the inputs and outputs that are related. Now, it's also very common for these lines to have an arrow like this on the end. The reason for that is, if we do it that way, then we do not have to label what our inputs and outputs are. okay? Because the output is the one that you point to, that you map to. So you can do it either way. You can use the arrows and not label. You could not use the arrows and label, or you could label and use the arrows. It doesn't matter, okay? But what you don't want to do is not label input and output and also not use arrows, because then it's not clear what your inputs are and what your outputs are. Okay, so I hope that picture helps you understand what a relation is. So here, I formally described what a relation is. It simply defines a relationship between two sets, the input set and the output set. Now, if I would have told you that up front, you would have been like, huh? So I think it was better to show you the picture first so that you can understand what this means. So now just to state some of the things I said about relations. The first thing is we will work only with real number inputs and real number outputs. Okay, so what that means is there will be um, no square roots, or how about even roots of negative numbers. Even roots of negative numbers are imaginary, which are not real numbers. So there will be no even roots of negative numbers or dividing by zero, fractions with zero in the denominator. When you try to divide by zero, you don't get anything. It doesn't make any sense. It's undefined. Okay? Now, something new, a new definition. The domain of a relation, okay, this is a very important word. Domain of a relation is the set of all inputs. A lot of people remember domain simply as inputs, and that's correct, but you have to be a little more specific. The domain of a relation is the set of all inputs that have real number outputs. Okay, you can see later on when we look at function notation that sometimes inputs may give non-real number outputs, and so those inputs are not in the domain. Okay. Now another term that's useful is the range. The range of a relation, I bet you can guess, is the set of all outputs. Okay. Now the domain. We commonly use the variable x to represent generic inputs, or domain elements if you want to call them that. So domain elements or inputs, generic inputs, are commonly represented by the variable x. Similarly, we commonly use the variable y to represent generic, you guessed it, outputs, or range elements. Okay? Now, why would we do such a thing? Well, because as you can see in a different video, the reason for using x and y is so that we can graph relations on the xy plane. Okay, so this allows us to do some graphing. All right, we're not going to graph in this video, however. All right, so now we understand what a relation is, what a mapping is, what the domain is, and what the range is. So now let's define what's called a function, which is an extremely important topic in mathematics. A function is a relation, okay? So it's a relationship. It describes a relationship between inputs and outputs. A function is a relation, however, where each input has exactly one output. Okay, so it's a very specific type of relation, and so an example that I always like to give to help students understand this, or an analogy, let's say, a function is like a calculator, kind of, you know. A function is like a calculator. We type type data into a calculator, right? We input stuff. We type data into a calculator and we expect, what do we expect? After we type all this in, what do we hit? We hit equals or enter or whatever the button is, and what do we expect? One answer. Okay? So that's the difference between a relation and a function. A function specifically gives one answer for each input or one output for each input. So let's go back and grab the relation R that we talked about earlier. Okay, so here's the relation R we looked at before, and the question is this relation a function? Okay? Every function is a relation, but not every relation has that special property of being a function. So how do we determine if this is a function? And anytime you're asked, any relation, if you're asked if it's a function, it's the same as asking, let's change the color of our text here. Let's see. Okay, so this is the same as asking, does each input of R have one output? Same question, okay? So anytime you're asked if something's a function, you need to look at each input and see how many outputs it has. So we can look at this right away, right? And we can see that the input of 3 has one output, two outputs. So immediately we can say the relation R is not a function. There is an input that has more than one output. And that's all it takes. If any input has more than one output, then it can't be a function, right? Because every input wouldn't have one output. And so specifically, the input of 3 has two outputs. And we could even name the outputs. Now, there are lots of other reasons. I mean, the input of square root 28 has one output, so there's nothing wrong with that input. There's nothing wrong with the input of negative 7.9 repeating because it has one output. But 7/12,000ths has three outputs. So there's another reason supporting that the relation R is not a function. Okay, so a function says every input value can only have one output value. I hope you understand relations, mappings, domain, range, and functions now.